go over questions from the practice final exam. In my opinion, the practice final exam is a good reflection of what the actual final exam is like. We probably will not have time to go over all of the questions in the practice final, but I would like to just give you some strategies in figuring out how to answer questions that you might see on the final. Okay. The first 4 questions on the practice final exam will be similar to questions that you will also see on the actual final, which present you with a situation, and I ask if any of the conditions to apply the central limit theorem are violated. Okay. So you know those conditions as the independent or randomization assumption, the big population condition, and the large sample condition. So for example, let's look at problem number 3. And it says a student has to conduct a survey for a school project. He goes around the school campus and interviews people he meets. He finds data from 100 people and finds that 45 of them answered yes to his questions. Are any conditions violated in this example? And the answer to question number 3 is that this situation violates the independent or randomization assumption, okay, or conditional. Because he's going around his school and surveying people he meets. That is not a random sample. So the results from this survey cannot be used for inference. And these are similar to questions that you saw in your 3rd quiz. And there are just a few more examples in the practice final exam. And so that's what you have there. Okay. As for on the practice final, it's questions 6 through 49. So the large portion of your practice final, as well as the large portion of the actual final exam, are going to be problems similar to what you saw on the quiz today, where I present a situation and I ask maybe 4 questions or 5 questions related to that. Okay, so I want to talk about strategies in answering these questions. And with that, to help you with that, I prepared this study guide for you. Let me just lower this screen. Can you guys still see the board? Okay, even though it's partly in shadow. Okay, so as you see here, it says when you read a problem, the very first thing that you've got to figure out is whether you have 1 sample or 2 samples, whether you're dealing with proportions or means. Okay? That is the most important step in answering these problems. If you mess this up, if you think you're dealing with proportions when you're dealing with means, you will have a bad time. If you think you have 1 sample when you have 2 samples, you will also have a bad time, okay? Because everything about how you handle the problem changes depending on whether you have 1 sample or 2 samples, proportions, or means. also changes significantly if you're dealing with confidence intervals or hypothesis tests, but that should become clear as you're reading the questions. It will make direct reference to a confidence interval or a hypothesis test. So that should be without question. But also, that is important. If you try to handle a confidence interval by using a hypothesis test, you will get all of these questions wrong. If you do the opposite, you will get those wrong. So, first thing that's important is to know whether you have one sample or two samples, whether you are dealing with means or proportions. So you have to ask, is the problem dealing with numeric or quantitative data, or is it categorical data? Categorical, you're dealing with proportions. Proportions mean you use the z-table. Numeric data, you're dealing with means. Means use the t-table, always. So if you have your study guide, you can annotate it. If you don't, you can write this down. You don't feel like you have to copy everything you see up on the screen because it's available on the internet as a piece of paper to print out. If you want to use the study guide as your note sheet, that is allowed. If you want to add notes in red pen or whatever other colored pen onto your study guide, that's also allowed. But this will count as your note sheet. You cannot have the study guide plus another note sheet. Okay, so everybody gets one 8.5 by 11 note sheet for the final exam. You can write on both sides. We have a question.
So we can type up the note sheet?
You can type up the note sheet if you want. If you want to shrink down the study guide and put that on one side of your note sheet and put your handwritten notes on the other side, that's also allowed. Do whatever you want, okay? But you have to make your own note sheet, okay? If I see two people have the exact same note sheet, I'm going to take them away, okay? You have to make your own.
Can we just paste this on the sheet?
Yeah, that's fine. That's fine. Okay. So read the problem. If you have a categorical variable, you're dealing with proportions. If it's numeric or quantitative data, you're dealing with means. Do you have one sample or two? As you're reading the problem, if you can identify two n's, meaning two sample sizes, then you have two samples. If you read the problem and you can only identify one sample size, one n, then you have one sample. Okay? It's as simple as that. If you've got two samples, there will be two sample sizes. They might be the same sample size used twice, but you will still have two sample sizes. Okay, so if you're dealing with confidence intervals, you might be asked questions like this. What is the center? What is the critical value? What is the standard error? What is the margin of error? Etc., etc., etc. In this study guide, I've listed how you should answer those types of questions based on the situation you are dealing with. Okay? So let's take a look at one of these problems from the practice final exam. Okay, so let's look at problems 5 through 10 on the practice final. Practice 5 through 10, practice questions 5 through 10 say, a farm wants to test two different diets for their cows to see which diet causes more weight gain. They randomly select 10 cows to give diet 1. They select 12 cows for diet 2. After 2 weeks on diet 1, the 10 cows gain an average of 15.2 pounds with a standard deviation of 4.1. After 2 weeks on diet 2, the 12 cows gained an average of 12.6 pounds with a standard deviation of 3.4. The following questions refer to a 95% confidence interval for the difference in average weight gain. Diet 1 minus diet 2. Okay, so you can see the problem right there. So don't shout out your answer, but think about this. Are we dealing with means or proportions? Do we have one sample or two samples? So think about your answer, don't shout it out. Means or proportions, one sample or two samples. Okay, so what do we have going on here?
Two sample test.
Two samples, and we're dealing with means. So it's going to be dealing with the t-distribution. Okay, and we're going to do a 95% confidence interval looking at our first question in that group. It says 5, 6, 7, 8, 9, 10. They say for a 95% confidence interval, what will be the center of the interval? Okay. Well, I can answer this, but if you are not sure, you can look at your study guide, and it says, what is the center? And it says, the center of the interval is the part that goes before the plus or minus.
We tried that out.
Huh?
So that's the answer.
No, that's not the answer, okay? You have to give me a number here. Okay. So, as you're reading this, what you're dealing with here is for two samples and means. Two samples means it's the difference between the sample means x bar 1 minus x bar 2. So number 5, what is the center of the interval? It's going to be x bar 1 minus x bar 2. And so in our case, what is x bar 1? 15.2. And what's x bar 2? 12.6. So our difference is 2.6. That is going to be the center of our interval. I hope we can read that. Number 6. What value would you use for T star? 95% confidence interval. What do you use for T star? Okay. Again, if you want to look at your study guide, it says for one sample and two sample means the T star comes from the T table. You have to determine the degrees of freedom, and you look up the confidence level. So the degrees of freedom for two samples is n minus 1, and we use the smaller sample. So our degrees of freedom is equal to n minus 1 using the smaller sample. So which sample is smaller? We have one sample that has 10 cows, another sample that has 12 cows. So we're going to use 10 minus 1, so my degrees of freedom is 9. 9 degrees of freedom. I looked that up in my T table, 95% confidence. So my critical value T star, 2.262. What is our standard error? It's number 7. Okay? Again, if you're not sure, you can look at your study guide. It says, what is the standard error? For two sample means, the standard error is given by this equation. S1 squared over N1 plus S2 squared over N2. And at this point, it's just a matter of plugging in the numbers that you find in your written in the problem. So the standard deviation from sample 1 is 4.1. We square that over 10 plus 3.4 squared over 12. It's directly from the problem. So once you know that you're dealing with two samples and means, you should know that, or have this figured out, that your standard error is that. And then you can go and calculate it out, and you get 1.626 as your standard error. losing anyone as I go along? S1 and S2, those are, standard deviations of sample 1 and sample 2, as written in the problem. Okay. So, 2 weeks on diet 1, the 10 cows gained an average of 15.2 pounds. That's the mean of sample 1, with a standard deviation of 4.1 pounds. That's going to be the standard deviation of sample 1, S1. The next problem asks us to make the confidence interval. So our confidence interval is going to be 2.6 plus or minus 2.262 times the standard error of 1.626. When I do that on the lower end, I get negative 1.078 to the high end, which is 6.278.
The 2.6 you got from the center, right?
What's that?
The 2.6 plus or minus the center.
Yeah, 2.6 is the center of our interval.
That's what you, and they don't give it to you. Sometimes they do give it to you. Do you have one sample?
Yeah, when you only have one sample, your sample mean is the center of the interval. But this is a difference between the samples.
You have to
Correct. Okay, so number 9 says, based on your 95% confidence interval, do we conclude that there is a difference in the average weight gain?
No, because 0 can be between.
Yeah. So when we look at our interval, the number 0 is in between -1 and 6.278. Okay. So 0 is in between the ends of our interval. Okay, so 0 is within the interval. That means we do not have evidence that there is a difference. Number 10 says, if instead we had made a 90% confidence interval, how would it compare to our 95% confidence interval? So would the 90% confidence interval have more spread or less spread than the 95% confidence interval?
Less.
Less. The 90% confidence interval would be more narrow than the 95% confidence interval.
Clarify for over 9 one more time.
Number 9?
Yes.
So we're asking, do we conclude that there is a difference between the average weight gain? Okay, so we're looking at, so this reflects on mu1 minus mu2. Okay? We want to know, is the quantity mu1 minus mu2, could that be equal to 0? Well, when we look at our interval, it goes from -1 to +6. 0 is in between -1 and +6. which means 0 is a possible or plausible value for the difference of mu1 minus mu2. Okay? If our interval was entirely positive or entirely negative, then 0 would not be a plausible value, and then we would not have evidence, or then we would have evidence that there is a difference. But because 0 is a plausible value, we do not have evidence that there's a difference.
So 0 was not between the negative and 6, but it would be, you do not.
So if our entire interval was entirely positive, so let's say it went from positive 3 to positive 7, then 0 is not within the interval. And then we would have evidence that there is a difference. Is that okay?
And then number 10, 90%.
So if you lower your confidence level, you can have a more narrow interval. If you want to be more confident, you've got to make your interval bigger. All right, we'll keep going. Questions 11 through 16 says, at the ruler and yardstick factory, a machine is suspected to be defective. The yardstick it produces are supposed to be 3 feet long, so exactly 3 feet long. You measure a random sample of 40 yardsticks and find that the average length is 3.02 feet with a standard deviation of 0.03 feet. Is this evidence that the machine is producing yardsticks that are too long? That's what we want to know. So we've got to make some hypotheses. But first off, is this a one-sided test or a two-sided test? How do we know it's one-sided? Okay, so it's saying, are they making yardsticks that are too long? Okay, so that would be a one-sided test. What would our hypotheses be? So for number 12, okay, well before we get started, do we have one sample or two samples? One sample. We took a random sample of 40 yardsticks, so we only have one sample. And are we dealing with means or proportions? Means. We're looking at the length of a yardstick, numeric variable. We're dealing with means. So if we're dealing with means and it's a hypothesis test, one sample, we can look at our study guide if we're not sure. But it says that we will use mu equal to some number versus mu something else. So we would want mu equal to 3. And we want to know if the machine is producing yardsticks that are too long, so we would have mu greater than 3. Those are our hypotheses. Number 13 asks, what is our test statistic? We're dealing with means, so we're going to use the t-distribution. And our test statistic is x bar minus mu0 divided by the standard error. Our standard error is s over the square root of n. So I have 0.03 divided by the square root of 40. And that's equal to 0.00474. 47434 actually. And so our test statistic t is going to be 3.02 minus 3 divided by 0.00474. .0047434. And again, this is equal to 4.216. Number 14. Find the p-value for this test. Okay. Well, how many degrees of freedom do we have? We do 40 minus 1. So we get 39 degrees of freedom. But the table doesn't have 39 degrees of freedom, so what do we use? We round down and we use 30 degrees of freedom. And our test statistic 4.216 is what? Is bigger than what we have at 30 degrees of freedom. So 30 degrees of freedom, the largest number that we have is 3.385. So our tail area is less than 0.001. Okay, because we are farther away from 0, so the amount in our tail is going to be less than the corresponding value that shows up in the table. So my test statistic, 4.216, is greater than 3.384, so my corresponding tail area is less than 0.001. So my p-value, whatever it is less than 0.001. Okay, number 15 says if alpha is equal to 0.05, what is our conclusion? We would reject the null. And what does that mean?
We have evidence
We reject the null hypothesis. We have evidence that the machine produces yardsticks that are too long. And number 16, if that conclusion was a mistake, so if the conclusion you just made was wrong, what kind of mistake is that? Yes?
I have a question.
Okay, question.
On our final, did you give us 4 different conclusions and we had to pick the correct conclusion?
Yes.
You read out the 4.7.
Yeah, so I might, maybe my answer choices, so for a final exam, the answer choices could be reject the null hypothesis. We do not have evidence that the machine produces yardsticks that are too long.
Would you say reject hypothesis? We have evidence of machine that all machines would that all sample those 2 words switch up the definition of it?
Maybe. Maybe.
What do you say?
Huh?
Would it be correct to say all machines produce yardsticks?
Well, this is we take 40 yardsticks from this machine that's suspected to be defective. So this is a sample for that particular machine. So our conclusions can only apply to that particular machine. To the population of all sticks made by this machine. Okay.
I'm confused with why are we rejecting the hypothesis?
We reject the null hypothesis because our p-value is small.
The p-value is
The p-value is less than 0.001. Our p-value is less than alpha, so we reject the null hypothesis.
okay, so if it was more than we would not.
P-value is larger than alpha, we would not reject the null.
You always provide alpha, right?
If I do not provide alpha, assume alpha is 0.05. Yes.
And how did you assign, why did you assign the null to be equal to 3 and not smaller?
The null hypothesis always has an equal sign. Okay? The null hypothesis always has an equal sign. So number 16. If the conclusion we made in number 15, which was to reject the null hypothesis, if that's wrong, what kind of mistake did we make? Is that a type 1 error or a type 2 error? This is a type 1 error.
Yeah, we never did that.
We didn't learn? No.
Yeah, we did it.
We didn't do it. Going back in time here. Okay. Type 1 error, I said, you never learned this. Never. Okay, alright.
Are we still gonna have it? No.
We'll have to make some changes then. Alright. Type 1 error, type 2 error. I'm gonna go back to these lectures that I've recorded today.
No, we haven't done it.
Haven't? Okay, alright.
Wait, what chapter?
That would be chapter 8. Chapter 8.
No.
Okay. Alright. I apologize. So we will skip 16 and I will make some modifications to the file again.
So we won't have questions like
I will not have questions related to material that we did not cover.
More questions until you know
Find suitable replacements. Alright, well, we'll keep going. 17 through 22. Researchers believe that 14% of the population is left-handed. A local school decides to see if their school students have a different proportion of left-handed people. The school has a total of 1,500 students, and they randomly select 90 students for the study. They find that 15 of them are left-handed. Is this evidence that the proportion of left-handed students at the school is different from the population proportion? Okay, we're going to deal with this problem, okay? And as you read the questions, you see you're dealing with a confidence interval. But are we dealing with one sample or two samples, and do we have proportions or means? One sample, and we're dealing with proportions. Okay, what is our sample proportion, number 17?
90 over 100.
Okay, so we want to know what proportion is left-handed. So our sample proportion, what is our sample size?
No, it's 90.
Oh, sorry.
90.
90.
Oh.
The sample size is 90.
And our, they
So-
say 15.
So, always figure out what your n is. N is 90, okay? And so our sample proportion, p hat, is going to be 15 over 90. 0.1667. Alright? Number 18, we're making a 90% confidence interval. What do we use for z star? Okay, this is just one of those numbers you have to know. 1.645.
Oh.
90% confidence interval. We're dealing with proportions, so you use Z. We're using 1.645. Number 19 asks, what is the standard error? It's going to be the square root of p hat times 1 minus p hat over n. Okay. Again, you can always look at your study guide and it says, what is the standard error? And it says if you're dealing with one sample proportions, it's going to be exactly that. So we just plug in the numbers that we have. 0.1667 times 1 minus 0.1667 divided by 90. We'll take the square root of that. And when we do that calculation, we get 0.0393. Yes.
Just a general question, are we gonna, for each of these questions, before we start the cluster of questions, we need to check our any conditions first, or so we assume?
No, all of these problems assume that the conditions have been met. I'm going to have a separate section at the very beginning of the test where you have to check for conditions. But as for these ones that involve inference, the conditions will be met. So you don't have to check them every single time. All right, what will be the center of our interval for number 20? Center is one sample proportion confidence interval. What do we use for the center? P hat. Center is P hat. So we use 0.1667. Okay, we'll go ahead and make the confidence interval. So we have 0.1667 plus or minus 1.645 times our standard error, which we found to be 0.0393. So on the low end, we have 0.1021 to the high end, 0.2313. That's our confidence interval. If we do the math, that's what we get. Based on your interval, is this evidence that the proportion at the school is different from the nation? What is the national proportion? 14%. So based on our interval, is our school's proportion different from 14%? No. What we see is that 14% is within our interval, so we do not have evidence that it's different from the national. 0.14 is within the interval. So we do not have evidence that the school's proportion different from the national proportion. Okay, next problem. You buy a bag of Starburst candies and a bag of Jolly Rancher candies. The bag of Starburst contains 80 pieces and 12 of them are cherry flavored. The bag of Jolly Ranchers contains 70 pieces and 14 of them are cherry flavored. Assuming these are truly random assortments, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of cherry flavored candies? Okay, so it says Group 1, Starburst candies, 80 pieces total, 12 cherry candies. Group 2, Jolly Rancher candies, 70 pieces total, 14 cherry candies. Okay. Form a hypothesis test at the 5% significance level. One sample or two samples, means or proportions?
Two samples.
And proportion.
Two samples and proportions. Good. So we're going to start dealing with this. What are the hypotheses? 23. Two samples, proportions. Our null hypothesis is going to be
P1
P1
minus
minus P2 is equal to
0.
0, and the alternative P1 minus P2
Not equal to.
not equal to, because the question says, do we have different proportion? So that's our alternative, not equal to 0. So 24 asks, what is P hat? P hat is the total success over the total observed. So we see a total of 12 plus 14 cherry candies divided by a total number of 80 plus 70 candies total. So I have a total of 26 cherry candies divided by 150 candies total. So my P hat is 0.1733. 25 asks for our test statistic. Which involves us finding a z-score, because we're dealing with proportions. And the z-score is going to be P1 hat minus P2 hat. We can include a minus 0 if we want, divided by our standard error. Our standard error is given by this P hat times 1 minus P hat, 1 over N1 plus 1 over N2. Again, if you're not sure what to do, you can always turn to your study guide, and it says what you should do. The test statistic is always this minus this, divided by the standard error. And so for two sample proportions, your standard error is that. So now it's just a matter of plugging in some numbers. So on the top, I would do 12 over 80 for P1 hat, and P2 hat is 14 over 70. And this is the standard error, so I'm going to put 0.1733 times 1 minus 0.1733 times 1 over 80 plus 1 over 70. Alright, so if you do all the math, you're going to get negative 0.81. Okay, so you're going to have to punch some stuff into your calculator to get it. So you can get it. Is everyone okay so far? So we want to know what our p-value is. 26. What is the p-value?
Okay,
So do I go to my Z table or T table? Z table. We're dealing with proportions, so we use the Z table. And I look up negative 0.81. How much do I have in the tail if I look up negative 0.81? I have 0.2090 in the tail. Do I have a one-tail or a two-tail test? Two-tail test. So my p-value is going to equal 2 times 0.2090. And I get 0.4180 as my p-value.
Why is it a two-tailed test?
Why is it a two-tail test? What was my alternative hypothesis? It was P1 minus P2 not equal to 0. Anytime you have not equal to 0 in your alternative hypothesis, it is a two-tailed test. That's the rule.